I want to talk about the Lotto 649 because I always think this is one of the greatest probability practical examples you can give to teach the topic of both combinatorics and probability. So the Lotto 649, if you're not familiar, it is a jackpot lottery, and you win the jackpot if you correctly choose 6 numbers from the numbers 1 through 49. Seems like a pretty simple game. Each ticket costs $3 to play. So let's talk about the actual odds or probability of picking those correct 6 numbers out of 49. There's 2 ways we can do this. We can think of this as, if we know our combination formulas, we can say this is 49, choose 6. Some people might write it like this, 49, choose 6. And what that means is, out of 49 numbers, we're going to choose 6 in any particular order. The order piece is really important. So in other words, if let's say the numbers are 1, 3, 5, 8, 7, 6, it doesn't matter if you pick them in that order or if you pick them in a different order. Order does not matter. So what's the formula for this? It is 49 factorial over 49 minus 6 factorial times 6 factorial. You can pop that in the calculator and you get 13,983,000, 13,983,816. So just under 14 million combinations. Now, one common mistake for calculating this number, people often say, oh, I've got 6 slots, 6 numbers to choose. I can choose the first one 49 ways, the next one 48 ways, the next one 47 ways, 46, 45, 44, and I can multiply all of these together to get the same answer. Unfortunately, you will not get the same answer. This is only the 49 factorial divided by 43 factorial. As we should be able to see, right? That would leave you with 49, 48, 47, 46, 45, 44. The reason this is not the same is because this is not taking into account the repeated combinations that are just in different orders. So let's say the numbers are 1, 2, 3, 4, 5, 6. This particular method of doing it is counting 1, 2, 3, 4, 5, 6. It's also counting 6, 5, 4, 3, 2, 1. It's the exact same 6 numbers, but in a different order, but the lottery does not care about that, so don't get tripped up doing that. Now, the real interesting part that I always like to tell students is, if there's almost 14 million combinations, how much would it cost you to buy every combination? Well, it's $3 per ticket. I'm just going to round this to about 14 million. $3 per ticket, $3 times 14 million is $42 million. So it would cost you $42 million to buy every single possible combination and be guaranteed to be holding the winning ticket in one of your 14 million tickets. So is this a good idea to do? Well, if you have a casual $42 million sitting around, maybe it is, but let's think about the sort of finances behind it. First thing, you would need the jackpot to be greater than 42 million. Obviously, we would never spend 42 million to make less than 42 million. Number 2, you have to hope for no splits. So there's no rule in the lottery that says 2 people can't have the same ticket, or the same combination on the ticket. So the second you split with somebody, the jackpot is, let's say it's 50 million. All of a sudden your share is 25 million. And the third thing to consider is taxes. So any taxes, depending on your federal or provincial, tax rules around lotteries, you may have to pay that. So you're buying your tickets with $42 million after tax dollars, but is the jackpot before tax or after tax? So unlikely you'll ever want to buy every single combination because you'd have to hope for no splits and have to worry about tax implications. But that gives you an idea of what jackpot number you would watch out for in order to think about that. So hopefully this was helpful. You can always send us more questions to info@arnoldtutoring.com. Thanks.